in this problem, we're going to take a look at finding the sample size to give a confidence interval of a certain width. So the problem reads as follows: is a pollster wants to construct a 95% confidence interval for the proportion of adults who prefer pineapple flavored gummy bears over the other flavors. And what we want to do is estimate the sample size needed so that the confidence interval will have a margin of error of 0.034. So the solution to that is we are going to use this formula here, which comes from the confidence interval itself, the form of the confidence interval, but it's solved for n, the sample size. And so the formula is that n equals p hat times 1 minus p hat, and that is all times the critical value z alpha over 2 divided by m, the margin of error squared. So again, n is the sample size, p hat is the sample proportion, z of alpha over 2 is the critical value, and m is the margin of error here. So that's the formula that we are going to start with in our problem. So n equals p hat times 1 minus p hat times z of alpha over 2 divided by m, that entire quantity squared. So what we need to do is to go through the problem and to figure out what we need to put for those two things. So we're trying to figure out n, the sample size here. So the first thing that we're going to need is p hat. And then when we go back and look through the problem, we are not given the sample proportion at all here. They just don't tell us what that is. So what do you do when they don't give you the sample proportion? Well, it turns out that this part right here, p hat times 1 minus p hat, the largest that will ever be is when p hat is equal to 0.5. And so that's what we need to do here. If they don't tell you what that is, what the sample proportion is, then we're going to use a value of 0.5 for that. And the reason why you want to do that is because, like I said, this quantity here, p hat times 1 minus p hat, will be as large as it possibly can be. And so therefore that will ensure that no matter what p hat truly is, right, whatever it comes out to be, that this sample size that we'll get no matter what will ensure that we have the confidence interval, the proper width that we want. So okay, so now next up we need to find the critical value, and to find the critical value you would refer to a table. You can also find it through a TI-84 calculator. So here we want a 95% confidence interval, so the critical value will be 1.96. So 1.96 goes in there. And now the margin of error that we want, the margin of error that we wanted to guarantee was 0.034. So 0.034 in there. So that's the calculation that we would make, right? And so what we're going to do is go to the calculator and put that in. I'm just going to type it in here in Desmos. 0.5 and then times 1.96 divided by the margin of error was 0.034. So that's what that calculation looks like. Make that a little larger. It's a little easier to see. So that's the calculation that we would have there. So, and then that comes out to be roughly around 830.796 roughly. So that's what that calculation comes out to be. And since we're talking about the sample size here, and that will be a whole number, what we need to do is just to round that up to the nearest whole number. So that will be 831 in this particular problem. And that's it.